Good morning. I am Dr. G. Satish Kumar, working as assistant professor in ECE department. Today, we are going to discuss about representation of signals, classification of signals, Fourier series, Fourier transform in signal systems. First, representation of signals. Signals is nothing but it contains or carries informations. Nowadays, we are using digital signals only. So far, the signals having digital informations. So the signals we can represent as unit step signal, unit ramp signal, unit impulse signal, rectangular signal, signal function. Now we can discuss one by one. First, unit step function. So unit step function here we can express as mathematically u of t equal to 1 when t greater than 0. Next, 1 by 2, I mean u of t equal to 1 by 2 when t equal to 0. Third case, u of t equals 0 when t less than 0. That means if t value greater than 0, then it implies all values are 1. When t equal to 0, then the u of t value is 1 by 2. If the t value less than 0, that is minus value, it goes minus, then the u of t value is 0. Here, u of t is nothing but unit step function. Okay, so for clearly understand, they give some graph. Here they mention, see, when t equal to 0, the value of u of t equal to 1 by 2. Okay, the x-axis as t, y-axis is u of t. Next, unit ramp function. Similarly, the unit ramp function here they mention ramp of t. When t greater than 0, you see ramp function is t. When t less than 0, the ramp function is 0. So next, the unit ramp function is the integral of the unit step function. It is called the unit ramp function because for positive t, its slope is 1 amplitude per time. Next thing is unit impulse function. Here, the unit impulse function is a derivative of the unit step function, or unit step is the integral of the unit impulse function. As a approach 0, then g of t. Here g of t is nothing but unit impulse function. G of t approach is a unit. So here the graph is clearly mentioned. Next is signum function. Here the signum function is closely related to the unit step function. Signum of t equal to 1 when t greater than 0. 0 t equal to 0. Minus 1 t less than 0. Next is rectangular pulse. The other name of rectangular pulse is gate function. So the rectangular pulse you can denoted as del A of t, where del A of t equal to 1 by A when t less than A by 2. The same time when del A of t equal to 0, t greater than A by 2. So this is the mathematical expression of rectangular function. Next, the representation of impulse function. The area under an impulse is called strength or weight. It is represented graphically by a vertical arrow. An impulse with a strength of 1 is called a unit impulse. So here they given two graphs. One is representation of unit impulse. Another one is shifter impulse of amplitude s. Next, up to now we discussed signals in time domain, that is u of t, like that. The same signal if it comes under u of n, x of n, that is a discrete signal. Okay, so here the discrete time signal is nothing but the sampling is acquisition of values of continuous time signal at discrete points in time. X of t is continuous signal, then x of n is a discrete time signal. Therefore, the x of n equal to x of n ts. Here, the ts is nothing but the time between the samples. Next thing is discrete time exponential signal and discrete time sinusoidal signal. First we will discuss discrete time sinusoidal signals. The discrete time signal can be defined. Here the discrete time short form they call dt. The dt signal can be defined in a manner analog to their continuous time counterpart. For example, take a sinusoidal signal in discrete time domain. So x of n, if they given x of t means that is continuous time signal, but here they given x of n. So x of n is denoted as discrete time signal. Okay. So here we will discuss discrete time sinusoidal signal. X of n equal to a sin 2 pi n by n naught plus theta. Here n by n naught, I mean 1 by n naught we can represent as a f naught. Therefore, x of n equal to a sin of 2 pi f naught n plus theta. This is discrete time sinusoidal signal. The same manner we can mention as discrete time exponential signal. The x of n equal to a power n. Okay, this is called exponential signal where n is nothing but discrete time. Theta is nothing but phase shifting radians. N naught is nothing but discrete period of the wave. And then 1 by n naught equal to nothing but f naught, that is discrete frequency. And then a is nothing but amplitude. So next, the discrete time step function or unit step function mathematically expressed as u of n equal to 1 when n greater than or equal to 0. The same time u of n equal to 0 when n less than 0. If n value are greater than 0, example 1 to 10 like that, therefore u of n equal to 1. At the same time it goes to minus 1, minus 2, minus 3 like that, then the u of n become 0. Next, unit discrete time unit ramp function. Previously we discussed unit ramp function in t. Now we discuss in n, that is continuous signal. This one is discrete signal. Ramp of n equal to n when n greater than equal to 0. When ramp signal of n equal to 0 when n less than equal to 0. Next thing is discrete time unit impulse function or unit pulse sequence. So here the unit impulse function we can call as del of n. So therefore del of n equal to 1 when n equal to 0. Del of n equal to 0 when n not equal to 0. If n value is 0, then only we can obtain del of n. In other values we cannot able to get because it becomes 0. That is del of n equal to del of an for any 0 finite integer a. Next, already I said signal is nothing but it contains some information. What kind of information? Analog information, digital information. So here the operation of signal is nothing but sometimes a given mathematical function may completely describe a signal. Different operations are required for a different purpose of arbitrary signal. So here the signal operation can be uh, classified as time shifting, time scaling, time folding or time inversion. First, time shifting. Time shifting is nothing but we can shift the signal from right side. It is called delay. Okay. See in the graph, the original signal x of t is shifted by an amount t naught. So t naught is nothing but t minus t naught is nothing but signal delayed. So we can shift right side. Similarly, left side means advanced. If we move right side, it is delay. If we move left hand side, that is advance. Similarly, time scaling. For the given function x of t, the x of at is the time scaled version of x of t. Here, the a value greater than 1, period of function x of t reduce and function speed up, graph of the function sinks. If for a less than 1, the period of the x of t increases and the function slow down, graph of the function expand. Next is time reversal. Time reversal is also called as time folding. In time reversal signal is reversed with respect to time, that is y of t equal to x of minus t is obtained for the given function. Next is classification of signal. Is very important part. It can be classified as first thing is deterministic, non-deterministic signal, periodic and aperiodic signal, even and odd signal, energy and power signal. So next system. Sorry. Okay. Next thing is Fourier analysis. The Fourier analysis is a tool that changes a time domain signal into a frequency domain signal and frequency domain signal into time domain signal. Therefore, we can analyze the signal from time domain to frequency domain or frequency to time domain. For the help of Fourier analysis, we can use. Next, Fourier series. Every composite periodic signal can be represented with a series of sine and cosine function. The function or integral harmonics of the fundamental frequency f of the composite signal. Using the series, we can decompose any periodic signal into harmonics. Uh, the mathematical expression for Fourier series is nothing but s of t equal to a naught plus summation n equal to 1 to infinity a n sine of 2 phi nft plus summation n equal to 1 to infinity bn cos 2 pi f nft, where a naught, a and bn are coefficient and a naught is nothing but amplitude function. Therefore, here we can individually represent what is a naught, a and bn in mathematical way. First thing is a naught equal to 1 by t integration 0 t s of t dt, and a n equal to 2 by t integration 0 to t s of t cos 2 pi n f t dt. Similarly, b naught equal to 2 pi t integration 0 to t s of t sin 2 pi n f t dt. Next, Fourier transform. Fourier transform gives the frequency domain of a non-periodic time domain signal. So next thing is inverse Fourier transform. While Fourier transform we can mathematically express as s of f equal to integration minus infinity to infinity s of t e power minus j 2 pi f t dt. Similarly, inverse Fourier transform is nothing but s of t equal to integration minus infinity to infinity s of f. Here the exponential term will be positive e power j 2 pi f t dt.